Hello everyone, we're going to understand this, how to convert the decimal number into binary number and binary into decimal number. This topic is really important, which comes often in UGC-NET and set examinations. So how we can do this? First, we have to understand what are the decimal number. So decimal number is simply data, a kind of data that we understand. The data that simply we call the analog system that we have. So these data we convert into computer language. So computer language, they don't understand this like very complex emotions that we understand. They just understand in two things. We call it on and off. And this is the two language, or just two things they understand. The machine understand these language. We call this binary. So by basically means two. So here, the on, when we are saying this, it just understand the 1, and for the 0, we take off, for the 0, we take. So we have to convert any decimal number into 1 and 0. How you can convert this? Here, this 2 we're going to use. This is a very significant number, so it will help us to convert any decimal number into a kind of binary number. So let's take an example. I'm just taking a simple example, which is, let's take it as 13. Okay. So there is a way to convert this. Start dividing this 13. So I'm dividing this 13 by 2. So on division by 2, it will come around 6. And when you're given the 6, you have to give one remainder. Okay. Now again divided by 2, so it will be completely divisible by 2. So 3 will come, and here 0 remainder will come. Now again we have to divide this. We will divide it by 2 again, and this will come 1, and here 1 will come as a remainder. So this is the number actually that we have got in the case of binary, we will say. So how we will write down this? Well, remember, there is sometime you'll find the question nowhere it is written decimal, but you can understand 10 at the suffix you'll find over here at the supposition. So basically decimal numbers are what? It starts from the 0, 1, 2 and goes on till 9. Okay, so they are the 10 decimals number. That's why we are writing 10 over here, and then the binary you can see 2. So the representation for the binary, we will start from this least to the most we will go, and we will start like this: 1, 1, 0, 1. And this is how we converted this decimal into binary, and we'll give the symbol of binary in this way. But this is a quite long method. Like if you're dividing with a certain big number, you will take it going to be get very difficult. Instead of doing that, we have a short trick, and I usually follow this. What is the short trick? You just remember when we were buying the chips, memory card, it was coming in 1 GB, then 2 GB, and then 4 GB, then 8 GB, then 12, and then 32, and then 64. You've never seen, I think, between these to 1.5 GB or 2.5 or 3 GB or like 5 GB. You might have seen this. And amazing fact from these number are that you can add up in a random way and you can get any number from these series. Okay, so like I can get any number before 7, before 8. I can get any number by adding this. So if I'm adding this, you can see if I'm adding this all 1, 2, 4, it is coming 7. And if I'm adding this 2 and 4, then it will come 6. If I'm adding this 4 and 1, it will come 5. And if I'm adding this 2 and 3, 2 and 1, so it will come 3. So you can see this any number you can get from these series. So this series is going to help us to understand how to find out the binary number from the decimal number very easily. So let's take this example 13 we were taking, and we will take the 13 again. So 13. Let's understand your kind of reasoning a little bit over here. What kind of number after adding this you can have 13 from this series? Okay, there's a little error we have done. It will not come. It will not be 12. It will be 16. Okay, so we have to add the number and we have to get 16 or 13. in this case. So let's see this one. You're seeing 8, and you can add this 8 plus 4, it will be 12. Then you can add 1. So by adding these three numbers, we can get 13. So what we will do, we are not using 2 over here. Okay. So if you're not using 2, then give the 0. If you're using 1, then give the 1. If you're using 4, and then give the 1. If you're using 8, then give the 1. And you can see this is the binary number easily we have got. You just need to remember the series, and you can get any number, any decimals numbers, you can convert directly into binary number, and this is much more easier to do that. You just need to have a little bit reasoning how you get it. Okay, remember, you just need to add. You can't subtract the number and you can get any number. You just need to add any random number, choose that, find which number will be most suitable to get this number. Okay, let's take another example. Suppose I'm giving you a kind of number 23. So you can convert the decimal number into binary number by this method, but we're not going to use this method. We're going to use this method. Okay, so how we will find this 23? Let's do this. So again, I'm writing this over here, the series. This starts from the 1, then 2, 4, 8, 16, 32, and then goes on. Okay, this number is smaller than 32, so we will not write 32, just 16 is enough. Okay, so let's do this. How we will do? I'm going to add the 16. I'm going to add the 16, then I'm going to add 4, and then I'm going to add 2, and then 1. After adding this, we can have this 23. And now what will be the number? We are using 16, so we will give 1. We are not using 8, we will give 0. And then we are using 4, we will give 1. We are using 2, we will give 1. And then using 1, we will give 1. And we can convert this decimal number into binary number like this. So it's quite interesting and easy to understand. Sometimes the question comes, they don't give you the positive number, they give the negative number. And they will ask, convert the number into the decimal number, the binary number. Let's take the example. I'm going to convert this 7, -7 into binary number. So how we'll convert this? Here, this little bit complexities comes, and we have to do this in a stepwise solution. Once you'll understand this, how to do this, you can do it very easily. Let's take the positive first. I'm not going to take the negative. First, I'll take the positive. So what I'll do, I'll again write the series. You can see 1, 2, 4, 8. Now this 7 you can see is less than 8, so we don't need to go further, just 4 is enough. Now you can see we can add these three number and we can get the 7. So I'm writing this all number we are using, so we will take 1, 1, 1. So what kind of binary number we have got? We have got 1, 1, 1. Okay, sometime in the question they will ask you the number of bits you have to write, like 5 bits you have to write. So in order to write like 5 bits, but you have written only 3. So you can give 0 extra. You can give n number of 0. It depends on the question or the situation. So I'm just giving you 2, 0 because the question may be asking here is 5 bits we have to write. Okay, so I've given 2 zeros extra. Now the second case is we have to find ones placement. Okay, sometimes the question also comes, they directly ask you the ones placement of a binary number. So what is the ones placement of a binary number? It's very easy. You just interchange the binary number. So if you're interchanging the binary number, then this 1 is going to interchange into 0, and this one in the same way it's going to interchange into 0, and this will be 0, and the 0 will interchange into 1. So this is one placement number. Most of the time question also asks that what will be the ones placement of this one. So this is the basic idea. Now we're going to understand what will be the binary number of this one. So we have to do what? We need to find the 2's placement. The 2 placement is nothing, just you have to add 1 in it. in the first term. Okay, when you're adding 1, it will be 1, and this will be 0, this will be 0, and this will be 1, and this will be 1. And that is the conversion of -7 decimal into binary number. Hope you understood this and you find the videos very interesting. Hope you like my video and support my channel. Thank you so much.